All right, but guys, let's get into our algebra. So on Monday, we sort of started talking about this sort of stuff again, revising what it means to have an algebraic expression and need to simplify it. But as we sort of start to do these examples, I'm going to remind you of a few things as we go along. And the very first thing I want to remind you of is always follow these 3 steps. So we've spoken about these 3 steps quite a few times, but if you can do these 3 things, you should be able to simplify any algebraic expression that you have going on. Vitaly, I see your math 24 there. Well done. That's another way that we can do it. Excellent. So guys, let's have a look at this algebra. So a couple math 24 answers, but let's have a look at our algebra now. So our first step when working with simplifying algebraic expressions, and because I'm just lazy, the instructions here would be simplify the following or fully simplify the following. But in essence, you need to make each of these expressions simple. The first thing that we always want to do is we want to identify our terms. Now we know that terms are separated by plus and minus signs. And so that's what we look out for when identifying our terms. Once we've done that, we want to simplify each term. So the individual terms that we've identified, we now want to simplify them. And once we've done that, we want to add and subtract our like terms. That's then simplifying the whole expression. All right, so if we can do these 3 things, we should be able to simplify any algebraic expression we have been given. So if we look at the first step and we want to identify our terms, okay, so I'm just putting a little purple star there because I'm going to do that in purple. Remember, when we identify our terms, we look for plus and minus signs, but we only look for the plus and minus signs outside or not inside a bracket or a fraction. So what I mean by that is we're going to ignore that negative sign because it's inside a bracket. I don't really need to consider that in the expression as a whole for now. The only plus or minus sign I have outside of a bracket or a fraction is this one over here, that minus. And what that does is it separates my first term from my second term. Okay, whatever. Oh, golly. Okay, so in this expression, I have got 2 terms that I am working with. So that's my first step done. I have identified each of my terms. Now my next step is to go and simplify each term. So when we want to simplify each term, basically what that means is we want to do any multiplication, division, or exponents that might exist in our expression. I'm just going to actually abbreviate that to exponent. So we multiply, we divide, or we deal with our exponents. That is what simplify each term means. So if I have a look at my first term, I can clearly see that I'm multiplying this coefficient of 6 into my bracket. And so I need to distribute 6 to the xy and 6 to the 2y squared. If I look at my second term, I'm multiplying everything here. So I need to multiply the -3, the x, and the y. Now, guys, remember, if you need to, have a little working out space for yourself on the side so that you are able to do your rough working or whatever the case is. But here we've got 6 times xy in my first term and 6 times -2y squared in my second term. I'm just putting it in brackets to remind myself that there is a negative and I need to be careful when I multiply. Sorry, my block was looking a bit weird. So if we take 6 times xy, we just get 6xy. So that's my first term once I distribute. And 6 times -2y squared, I'm going to break this down, SNV. So signs, numbers, variables. Guys, we need to focus, otherwise we're not doing this. A positive times a negative is a negative. 6 times 2 is 12. And then we've got the y squared. So this simplifies to -12y squared. Then I need to go and multiply in my second term the -3, the positive x, and the positive y. Now you can remember, or you can put in the ones in front of your variables if you would like to. But essentially you've got a negative times a positive, which is a negative. 3 times 1, which is still 3, and then x times y, which is xy. Once you have simplified each of your terms, so once step 2 is complete, you can now move on to step 3, which is to add and subtract your like terms. Now, this is where we actually need to go and identify our like terms. So the 6xy and the minus 3xy are like terms because they both have xy in them. And this negative 12y squared is a completely separate term, okay? It only has a y squared, it doesn't have an x, and the y variables have got different exponents. And so it is a separate term to the others. Once I've identified my like terms for myself, I can now add them. So the 6xy minus 3xy, think of your number line. 6 minus 3 gives us 3xy. And I can't do anything with this minus 12y squared because it doesn't have any like terms and isn't a like term to the xy terms. So that's it. I've added all of my like terms. I don't have any other like terms to deal with. And so I have simplified my expression. Right, for those of you saying you don't understand, first thing, this has been done. So if you're not understanding, you need to go and watch the videos that are on Watobe's website or on YouTube. Second thing, I'm going to run through this again. And if you still don't understand, like I say, you need to go and watch the videos. So the first thing that I did was I identified my terms. That I have done in purple, right? I saw that the minus sign, so if we have a look here, I saw that this minus sign over here separated my terms. And so I had my first term and my second term. That was step number 1 done. Once I had done that, I needed to simplify each term. What that meant for me was that I had to go and distribute the coefficient of 6 in the first term. And in the second term, I needed to multiply all of those factors or all of those values together. Once we had simplified our terms, so once I distributed the 6 into the bracket, and once I'd multiplied the negative 3 times x times y, I then looked for my like terms. My like terms I've underlined here in the green. So the 6xy and the negative 3xy are like terms because they've got the same group of variables. We were on step 3. Like terms, we've identified the like terms, and then we added our like terms. So the 6xy minus 3xy gave us positive 3xy. This negative 12y squared was a like term or was a group of terms all by itself. It didn't have any like terms with it. So it meant it stayed exactly as it was when we simplified. And that is how we ended up at our answer. We cannot do anything more with our answer because there are no more like terms. And so that's where we stop. Please take your screenshots. I would like to say if you have any questions, you may raise your hand. But again, guys, if you aren't listening, then in case it's not obvious, I'm in no mood to waste anyone else's time. So if you've got questions, please raise your hand or put them in the chat. Otherwise, we're moving on.
Yeah, well, guys, and we're going to make it fun. Like I said, Teacher Sam is very lenient, right? So she has taught you a lot of things. So you better have listened because we're going to rush over everything because it's a revision. Okay. So Tulu, you can ask your way the question.
Good afternoon, ma'am.
Afternoon.
Ma'am, can I please ask, after simplifying your terms, do the exponential numbers stay together?
When you say stay together, what do you mean?
Like, ma'am, let's say you have 12y3, cubed.
Mm-hmm.
Does it stay like that? You don't change it?
Oh, okay. I think I'm on the same page now. So, guys, basically, when we add our like terms, so when we're in step 3 here and we're adding and subtracting our like terms, the exponents don't change when we add and subtract. So yes, if you had xy, it's going to stay xy. If you had y squared, you're going to have y squared. Exponents only change when we multiply or divide, and because we're adding and subtracting, there's no reason that the exponent should be changing. So yeah, they stay exactly the same. So Tolfelo, does that answer your question?
Yes, ma'am.
Cool. Right, nice. Jackie?
So, ma'am, I literally don't understand. Like, I'm confused because at our school, my teacher told me it was how different things.
Okay, well, what were you told?
Well, she first said, like, we must remove the brackets, put xy with 6, and then we subtract 6xy minus 2y to the power of 2. And then the answer we get, she says we must subtract it from the second term, of which the
Okay,
second
so
term is xy.
you can't just subtract everything. You have to look for the like terms. If you are just subtracting everything in your expression, you're not considering what your like terms are. So we've done the same thing that your teacher has told you to do by getting rid of the brackets that we did through the distribution. So by multiplying the 6 into the brackets, we do that. But once you've done that, you have to look for like terms. You cannot add the 6xy and the 12y squared. They're not the same. It's like adding apples and hammers. It just doesn't work. You have to identify your like terms. So here, as our final answer, I can't now go say 3 minus 12 because that's not mathematically correct. So you have to identify your like terms in order to add or subtract them. Okay.
Yeah.
Cool. BK?
Oh, ma'am. Okay, ma'am. This makes total sense, ma'am. But I've only one question, ma'am. If one of the variables had like a number like 2, for example,
So
ma'am.
like, yeah.
For example, ma'am, 6 bracket x 2y minus 2y to the power of 2. What will happen then, ma'am?
Okay, I'm assuming when you say 2, you're talking about an exponent. So it would be like 6x squared y.
Yes.
Okay, so then they wouldn't be like terms. So now you would have 3 different groups of terms. You wouldn't be able to add any of them. And so you would just stop there. So BK, if there was an exponent, it means that you no longer have those like terms. You can't add or subtract them. So if, however, they both had a squared, so it was x squared y, then again, they become like terms because the set of variables are identical. And so then you can add and subtract them.
Okay.
Okay. Sorry for interrupting you. All right, guys. So I'm assuming you've all got your screenshots. Let's have a look at another one. So if we have a look at question B, again, we're going to follow those same 3 steps. We're not going to change our sort of method. We're not going to change what we're doing. We're going to do the same 3 things. So first thing, we want to identify our terms. Now remember, to do that, we look for the plus or minus signs not inside a bracket or a fraction. The only one we have here is then that negative, which means we've got our first term and separately our second term. So in this expression, we have got 2 terms that we are dealing with. So that's step number 1 done. Step number 2 is, step number 2 is to then simplify each term. Now, sometimes it works out that we don't have to simplify all of our terms. What I mean by that is, if we look at our first term, I can't simplify 7a squared. It is 7a squared, that's it. So that's not going to change at all, but I can see in my second term, I've got a fair amount that I need to deal with. I have an exponent that I have to deal with, and I have this coefficient of -2 that I need to deal with. Now, guys, if you are super comfortable with this stuff, you can probably do this all in one go, but I'm going to do it step by step. Now, remember, according to bodmas, and let's just write that up here, bodmas or bedmas, doesn't really matter. I'm going to say bedmas. but if you prefer bodmas, that is fine. We do brackets first, but there's nothing inside my brackets that I can simplify. It's negative 3a. Then I move on to my exponent. Now, what we need to remember is that that exponent of 2, or the squared, is telling me that I'm taking that bracket of minus 3a and I'm multiplying it twice. I'm still going to deal with the negative 2 coefficient in a second, but this exponent means that I'm multiplying this bracket twice. So I'm going to start with that multiplication. A negative times a negative is a positive. Let me just write everything else down for now. Whoopsie. Is a positive. 3 times 3 is 9. A times a is a squared. Okay, so I have dealt first with the exponent because that's what bodmas tells me to do. Bodmas then tells me that I can go and do division or multiplication. And I can see that I've got multiplication that needs to happen here with the negative 2 coefficient. We've got our 7a squared, that's not changing. But now we need to multiply the negative 2 and the 9a squared. So a negative times a positive is a negative. 2 times 9 is 18. And then we have our a squared. That's our second step done. Our third step then, remember, is we want to add or subtract. I don't know why I want to write all these words out. Add or subtract like terms. And this is now where we look for same variables, same exponents. Now, what I hopefully see here is that both of these are like terms because they both have an a squared only in them. And so that means I can go and add and subtract them. Right, now guys, remember, hopefully I make this number line big enough, but I never do, so we'll see what happens. Remember that when you are adding and subtracting values, we need to be very, very careful. Now, obviously, you could just grab a calculator and you could do this and you would be absolutely fine. If you're not super comfortable with a calculator or you're not allowed to use a calculator, remember to just draw a number line for yourself, and that should help you add and subtract any integers that you are working with. So here we are at positive 7a. We want to subtract 18a squared. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, golly. 16, 17, 18. So that takes me all the way down to negative 11. And as we said in this last example, the exponents don't change when we add or subtract. So this will stay a squared. So I have managed to simplify this term because of the like terms that we had all the way down to negative 11a squared. Now, again, if you're not comfortable with the adding and subtracting integers, use your calculator or use a number line. Either one will get you where you need to be. In this case, we dealt with the exponent first because that's what bodmas or bedmas tells us to do. And then we followed our steps exactly as we always do. We follow our 3 steps and we are able to simplify. Right, so screenshots. And if anyone has any questions, please can you raise your hand and I will help you. Botale?
Ma'am, I wanted to ask, ma'am, you see the one about like brackets 3a to the power 2, ma'am. Don't we like distribute the 2 into the brackets, or do we like separate?
So you can. The reason I chose to rather write it as 2 brackets is because sometimes we forget what it means to square a negative. So if you want to distribute, that is absolutely fine. But remember, you're distributing the 2 to the negative 3 because that has an exponent of 1 and to the a. And if you've got negative 3 squared, that gives you a positive 9. So as long as you remember what it means to square a negative, that you're going to end up with a positive, I don't mind if you rather choose to show the distribution. That's absolutely fine.
But ma'am, if you like distribute the 2 into the brackets, only like give you 6.
No, because remember, you're distributing exponent to exponent.
Oh, thank you, ma'am.
Okay, guys, that's really important. When you distribute an exponent into a bracket, it is exponent times exponent. You cannot times the 2 and the 3 because the 3 is a coefficient, it's not an exponent. So we multiply the 2 to the exponent of 3 and the exponent of a, and then we've distributed, but not to the number. Right, Jadely?
So, ma'am, I want to ask, aren't you gonna simplify negative 11 to the power of negative 11a to the power of 2?
I can't simplify it anymore because now it's one term. I'm not timesing it, I'm not dividing it, there's nothing being added or subtracted. I can't do anything else.
Okay, ma'am.
Okay, so because we've got no more like terms and because it's just one single term, I can't do anything. Okay, and BK.
Okay, man. The one thing I don't, the one thing I understand, ma'am, right, and I don't understand, right, ma'am, is the brackets, ma'am. I know you have to distribute all of them, right, ma'am? But I like Philly, so what if like -2 had a like exponent? What then?
So I mean, if we wouldn't really give you something like that, but if we did and it had an exponent, my advice would be to simplify it. So let's say it was -2 squared, I would simplify that to -4 because 2 squared is 4, and then I would do exactly the same thing as what I've done here. I would distribute. So generally your coefficient, unless it's got a variable, won't just have a random exponent attached to a number. We can have a coefficient, say for example, of like x squared, but then we apply our exponent laws. Yeah, what's important here is that you understand the fact that this -3a being squared is us multiplying it twice.
Okay,
because that's what squared means.
Yes, ma'am. Interesting,
Okay.
ma'am.
All right, guys, I hope you've all got your screenshots. Let's try another one. I'm just going to wait 2 seconds in case people don't. Alrighty, so I want you to have a look at this. I'm not going to just send you off into the wild. I want you to just look at this, and I want you to, on the chat, tell me how many terms you think this expression has. Remember, we are looking for plus and minus signs that are outside of brackets or fractions. So in this case, we ignore the sign inside the bracket. We only want the plus and minus signs outside the bracket in order to identify our terms. So on the chat, I want you to decide how many terms you think this expression has. Okay, we've got a bit of a mixed batch. Let's keep them coming. Okay, it seems like the overwhelming majority are saying 3, which is awesome. If we have a look, remember we want to get our plus and minus signs outside of the bracket. So there's a minus sign, there's a plus sign. Those are the ones that are separating my terms. So this whole 2 times the bracket is term number 1. The -4a is term number 2. And the 3a times 3 is term number 3. So we have actually got 3 terms in this expression. The 2 times the bracket, the -4a, and the 3a times 3. So that was my very first step that I needed to do was to identify my terms. The second step is I now need to go and simplify each of these terms. So if we think about how we can simplify, in the first term, I obviously need to distribute the 2 to both of those terms. The second term, I can't do anything there really. But the third term, I need to multiply those 2 together. So guys, what I want you to try is to simplify this expression. I've told you what you need to do to simplify each terms. So you need to go and simplify the terms and then look and see if you have any like terms that you can add and subtract to fully simplify. So I want you to try. Put your answers in the chat. Let's see what we get. We will obviously go through it. Let's see what happens. Okay, so remember, you are distributing in your first term, you are multiplying in your third term. The second term doesn't have anything going on in it. It just stays, what was it, 4a. Guys, your variables shouldn't just disappear. Unless your like terms all cancel out, which in this case they aren't going to, you should still have some variables going on. Oh, mixed bag of answers here. Right, guys, let's have a see. Okay, so in the first term, you might have noticed that 4a and 7a are actually like terms. So you could have first subtracted them before distributing. I'm just going to keep it as we said that we're going to distribute because it really doesn't matter. If you saw the like terms and you subtracted and then you multiplied by 2, you will get exactly the same answer. However, if we distribute, 2 times 4a is 8a. 2 times negative 7a, a positive times a negative is a negative. 2 times 7, 14, and then we've got the a. So that's the whole first term simplified. Then we have that minus 4a. Remember we said that it doesn't do anything. Oh, there's nothing that I can do to that specific term. There's no multiplication, division, or exponent, so it just is. And then in my third term, I need to multiply. Positive times a positive is a positive. 3 times 3 is 9, and then we've got our 9a. Now, hopefully what you see here, guys, is that all of these are like terms. All of them have a only as their variable. I don't know, my highlighter is excessively small at the moment. All of them have just a as their variable, which means they all fall in the same group of like terms. So now we can go and add and subtract. I'm just going to use the same number line that I had here because I'm feeling lazy and I don't want to have to redraw. Right, so let's see if I can just copy it. Right, if we go and have a look at our number line. And the reason, again, we use number line is if we're not allowed to use a calculator, number lines are very useful. If you can use a calculator, honestly, use a calculator. So here we are at 8a. we want to subtract 14. So 1, 2, 3, 4, 5, 6, 7. Oh, golly. Okay, let me try that again. It's not getting any better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Apparently that's a straight line. Whatever. Here we are at -6. From here, I now want to subtract another 4. 1, 2, 3, 4. So here I am at -10. But now all of a sudden I want to add 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So where I end up after I've done all of my addition and subtraction is at -1. Remember we said the variable doesn't change, it stays exactly as it is. So our final answer here is -1a. If you wrote your answer as just -a, that's absolutely fine. Remember, you don't have to put the coefficient of 1 if you don't want to. You do have to have the negative, but you don't have to put the 1. So you can either have -1a or -a. So again, because all of the terms were like terms in the end, it simplifies all down to one value. Right, screenshots, hands up for questions. Otherwise, we move on. So if you've got questions, you can raise your hand. That's what I mean.
Tender, you can ask away.
Hello, ma'am. Can you hear me?
We can?
Ma'am, in the beginning, you said how many terms are there in this expression, and you said there were 3. Instead, I thought there were 4. So isn't that the multiple sign? Is it not separating 3a and 3?
No. So remember, the only thing that separates terms are plus and minus. If it's a multiplication or a division, that's still one term.
Okay, ma'am.
Okay.
Thank
So
you.
guys, that's really important. Like the Tender said, it is only plus and minus signs that separate terms. Okay?
Ma'am, I'm also agreeing with the other guy, whoever his name is. Ma'am, how, like, this is another topic, ma'am. Isn't the minus separating to 2 groups, ma'am? Because I said it was 2 groups. Isn't it two groups because there was a bracket here, the 2 comma 4a minus 7a close bracket. Isn't that one? That's one term, right? And then minus 4a. I thought that was minus 4a plus 3a times 3. I thought that was another term.
So remember, terms are separated by plus and minus signs. So that and that, oh golly, separates my term. So that is the separation. So I've got 1, 2, 3. Okay.
Interesting.
So guys, in the last few examples, we generally had minus signs, I think, that were separating terms. So there we had a minus separating 2 terms. Here we had a minus, but it's not just minus, it's minus and plus, and you need to remember that. Okay, otherwise you are going to incorrectly identify your terms. Right. Let's have a look at our next example here. We're going to work through this one together, just because there's a little bit here that we need to be careful of. So again, we're going to identify our terms. But what I want you to remember is that this negative in front of the bracket has a 1 attached to it. So it's actually a coefficient of -1. And that has been multiplied with the bracket. So there is not actually, there is a minus sign there, but it's attached to a coefficient which has been multiplied. And so what that means is that this plus sign is separating 2 terms only, okay? We wouldn't consider this minus sign as separating terms unless there was a number in front of it. If I had 2 minus the bracket, then I would have 3 terms, but I don't. I've got 2 terms here separated by the plus sign over here. So that's the first very important thing to see. The next thing is that in my first term, I actually have 2 coefficients. I've got this -1 and I've got this 2. Hopefully what you're seeing is that, I don't know why there's suddenly a B here. Hopefully what you're seeing is that this bracket has 2 things being multiplied to it. So we've got the -1 being multiplied, but we also have the 2 being multiplied. Now, if you want to distribute it exactly as I've just done, that's fine. But we can make our life easier. We know, hopefully, that the order of multiplication doesn't matter. If we say 3 times 2 times 1, we get 6. 6. Oh, I've got hiccups. 2 times 3 times 1 is 6. 1 times 3 times 2 is 6. And I could keep going. It doesn't matter what order I multiply in, I get exactly the same answer. And so what that means is whenever we have got 2 coefficients to my bracket, what I'm actually going to do is I'm going to multiply them together. So -1 times 2, which gives me -2. And then I'm going to have my bracket. What this does is it allows me to distribute once only into my bracket. So again, let's do this. When we have 2 coefficients to the bracket, we times the coefficients and then distribute. Right, it's not a must. You don't have to do it like this, but it does make life easier because now you're not doing 2 sets of distribution. You're only doing the distribution once. Okay, what that means is that now we can see exactly how we need to simplify our terms. So we're going to distribute. -2 times 3p gives us -6p. -2 times -4m, a negative times a negative is a positive. 2 times 4, 8. And then we have our m. And then we've got that second term of 6p. Now I check for my like term. So I see I've got a -6p and a +6p. And then as a completely separate group of terms, I've got my +8m. Remember, I've said this to you many times before. If you feel more comfortable writing your like terms right next to each other and grouping them first before adding or subtracting, by all means, go for it. You don't have to, but you can. Right, next thing that I want you to see is, if you have 3 minus 3, they cancel, you get 0. If you have -4 plus 4, they cancel, you get 0. If you have -x plus x, they cancel, you get 0. And so what we need to see here is that with our like terms of -6p plus 6p, they actually cancel each other out. We end up with 0. And so all we have remaining is the 8m. And we have simplified our expression. Grade 8, it doesn't help me to just say I'm confused, I don't get it, blah, blah, blah. Be specific, otherwise I can't help you. I'm going to run through this again. So if you are feeling confused, please listen. Otherwise, go watch the videos as I have said. So if we go through this again, we have got 2 terms. We've got the minus times the bracket times 2, term 1. And term 2, we've got 6p. So I need to go and take term 1 and simplify that. Now, because I see that I have got 2 coefficients to my bracket, I have got 2 things being multiplied into my bracket, the -1 and the 2. I'm going to times those coefficients together, and then I'm going to distribute. So -1 times 2 gave me -2, and then I distributed that into my bracket. So I multiplied into my bracket. -2 times +3p gave me the -6p. Negative 2 times negative 4m gave me the positive 8m. Negative times a negative is a positive. And then I still had my 6p, that was my third term from the original expression, right at the end here because I didn't do anything with it. I couldn't simplify it further. Remember, once we've simplified each term, our third and final step is to add and subtract our like terms. So I identified my like terms. I had minus 6p plus 6p, and then the plus 8m as a separate term. The minus 6p and the plus 6p cancel each other out. I've explained that over here. When you add the inverse of the other, or when you add the inverse of a value, so minus 7 plus 7, or 7 minus 7, doesn't really matter the order, you are going to end up with 0. So they actually fall away. They cancel each other out. And that leaves you only with the 8m. Can't do anything with that. It is one single term, not being multiplied, not being divided, doesn't have an exponent. So that's it. I have simplified to 8m.